Hi, good afternoon. Joe Rasm here from 3D Systems here at the Technology Incubator, Knowledge Park in Rock Hill, South Carolina. I'd like to introduce you to Dr. Andrew Besmer from Winthrop University. Hi, Andrew.
Nice to meet you. So I am from Winthrop University. I teach computer science there at the university. So we have a semi-large computer science program where we're training the next set of students to build worlds that look like the one we're about to show you. So I want to show you a little bit about this project that we were involved in over the first half of this year. We basically were holding a Internet of Things themed hackathon that took place over the course of 4 months. So a very long, very intricate, detailed hackathon where our theme was actually to take this space, the technology incubator space, and transform it into an Internet of Things connected space. So prior to our involvement, there weren't any Internet of Things devices in here, and now since we've left, we have custom IoT devices, we have off-the-shelf consumer-level IoT devices, and we have Amazon Alexa. So all of it working together in a cloud-based scenario. So each one of the projects that you see here today, they're all cloud connected. So none of them are hardwired to each other. They all send and receive their signals from the cloud. So some of the devices that you see are publishers, and they sort of publish data up to the cloud to be consumed. And other ones are subscribers, and they will subscribe to the data, and they'll use that data in whatever way it makes sense. So when you look at a project like this one, where we have an overview of the space as it's currently being utilized, you'll actually see that this project here isn't hardwired to any motion sensors or door sensors or anything like that. It's just connected to the cloud, and it's subscribed to all those events that are happening, like doors opening, motion happening in the space, and so on. We take that data and we create this visualization of what's going on in the space. And the reason we're doing this is one of the things that the space wanted to be able to do was know which conference rooms are being utilized, right, at any time. So one of the problems they have is being able to know, is that conference room free, or is somebody actually, using it, because people can come and go through the technology incubator at any time, any of the clients. So what you see here is that the conference room that we have right here, this one's in use, and the reason it's marked in use is because we just walked out of there. So we had a presence in the room, and so therefore it assumes that we're currently utilizing it. And you can see that the conference room at the back of the building actually is not in use. So we haven't been back there in a little while, so it's actually reclaimed that as being a free space for us to use. All of this happens live, so if I were to open and close a door, you'll see that the indication of whether the door is open, green, or closed, red, would update in real time. So you can imagine that outside the tech incubator, people might use this for safety, to know whether or not a door has been left open when it shouldn't have been propped open, or justifying utilization costs, or do we need more conference rooms? Are they truly being utilized at the level people say that they really are? By recording and looking at that data over a period of time. Each one of these sensors, in contrast to the way things were in the past, is broadcasting data 24/7, 365. So you can get very rich, very detailed data about the utilization of your spaces. This is another project that we've got here. So this is a good example of what you would consider maybe an edge device. This device here is a Internet of Things connected recycle bin. And we talked about this, although we didn't build it. You could even build sensors into this to indicate when the recycle bin was full, so that could trigger somebody to actually come out and service the space and replace the recycle bin. So they don't need to come out if not a whole lot of recycling's happened, and they will come out when it's ready. So what we have here is a good illustration of what the after looks like if we actually did use 3D printing as part of one of the projects. So what you see here is all the components actually put inside of a 3D printed form factor. So we have a perma-proto board that's actually been measured and then designed so that there are mounting holes inside the box that we have here that fit perfectly for that perma-proto board. One of the reasons we chose to actually do the 3D printing instead of actually using, for example, off-the-shelf boxes is when we were looking at off-the-shelf boxes, they actually would have worked for a project like this, but they wouldn't have really fit into the space. So it would just be a sort of a box that was just mounted to a wall. It didn't really bring in the concept or the feel that we had about making this a technology space, making it very modern, very high-tech. And so we worked on illustrating what this file would be using a CAD program. And then we had to iterate on it because what we found is as we started to do our designs, if you put 6 legs on here, it looks like a spider, and it doesn't look like any kind of technology. So we iterated, we added some additional shapes instead of just one type of leg. We have multiple types of legs on here, varying amounts on different sides, and eventually we got it something that we thought looked pretty decent for being able to put up into the space. And so over the 24-hour period that we were spending here during our wrap-up event, students were printing out cases and designing their own cases and making modifications to cases so that we could hold other components and things like that that we hadn't originally anticipated. We were able to do that in 24 hours, so pretty incredible